Hello, and welcome to a little video on chapter 4, which is all about comparing data sets. This unit just kind of expands on the big three, which you've already been working on, so it shouldn't be too much of a stretch. There are some new graphs that you want to be thinking about, like time plots and stem plots and things like that, which may be a little new. And also, re-expressing data is new as well. So we're going to talk about that real quick. So I have a little data set. This is just from the textbook, one of the homework problems that are in there. Number 8 is talking about the campsites at different states, how many campsites they have available. So we got Wisconsin and Vermont here, and you can see the frequency and then how many they have here. So these are histograms, like how many campsites at public parks, right? So we're supposed to compare these things. Now, when you compare things, the big three is what you want to focus on. You're going to, like, whoever is grading your paper is going to be looking for those three things. But when you have two sets, you want to be using comparative language. And that's the most important thing. This is larger than this, or this is smaller than this, or these are approximately the same, right? That comparative language. You can't just say this is 10 and this is 5. That's leaving the reader up to say which one's bigger. I know it seems obvious, but you have to write it down. You have to say this one's 10, this one's 5, which means this one is larger than this one, right? When you're going through the big three. Now, of course, to review the big three, we got the center, which is mean, median, or mode. Usually we use the mean if your data is symmetric, but if your data is skewed, we want to use the median. For the spread, you can use standard deviation, range, IQR. Those are all good things. But again, if your data is symmetric, the standard deviation is great. But if your data is skewed, you want to be using the range or the IQR, usually the IQR. Then for shape, we're looking at different words, right? Usually we focus on, is it symmetric or not symmetric, like skewed or not. Then we want to focus on, is it uniform, which would just mean that it's flat, right? That would be uniform. Or is it unimodal, right? Unimodal or bimodal with two modes, something like that. So usually it's about, like, is it symmetric, first of all, or is it skewed? And then is it, what kind of overall shape does it have? Is it unimodal? Is it bimodal? Is it uniform? If you have a set of data that is symmetric and unimodal, then it would be approximately normal in shape. And then we can use all our normal tools, like things we're going to do with normal curves. So it's very specific. If you want to use a normal curve, your data has to be symmetric and unimodal. Anyway, back to these two states. So for Wisconsin, you can see that it's kind of peaked on the left more than it is on the right. So we would call this skewed to the right, or better is skewed to the higher numbers. Same thing with Vermont. They are both skewed to the higher numbers. So for the shape, I would say they are unimodal. They just have one mode here. Both are unimodal and skewed to the higher numbers. Okay, for the mean and the median, these are skewed, so we don't want to use the mean. The mean really affects, like, this large value and this large value. They're going to affect the mean. They're going to pull the mean up higher and kind of change your thinking about what's going on. Like, it's going to be misleading a little bit. So it's better to use the median when you have skewed data. Now, in reality, I'm supposed to be counting these things and going, oh, there's 10 of these, 2 of these, 1 of these, and adding them up, and then find out where the median is and report that median and compare it to the other one. I'm just going to take a quick estimate here, like 10, 12, 13, 14, 15, blah, blah, blah. It's probably right in here somewhere, about 50. This one is also skewed to the right, but you can see it's a little more compact. It looks like I don't know. It looks like maybe the median is probably a very similar place. I bet they have very similar centers. Now, if I was going to report the mean, this one would have a larger mean because of these numbers are going to pull that mean over this way. So it would have a larger mean, but it probably has very similar medians. Okay, that's why we report the median in the first place. So I would say very similar medians. They're both skewed to the higher numbers and unimodal. The IQR or maybe the range. This, like, I'll do both, but the range of this is, you can see, is quite larger than the range of this one, right? So that would be something you want to talk about. Oh, the range for Wisconsin campsites is like 480, while the range for the Vermont campsites is like 280. So the Wisconsin campsites is larger, right? Something like that. All right. And then if you use the IQR, you probably get something, I don't know, maybe about, I'd have to count, right? And on a real test, you're supposed to count these out, like actually count out and find out where your quartiles are. And we're going to do that on the next problem. That's why I'm not doing it right now. Save a little time. But again, I don't know. I guess is that the middle 50% of each of those data sets? Maybe I overstated a little, but they look pretty similar, like this kind of middle 50%. And this little middle 50% looks pretty close to each other. So again, I wouldn't really say larger or smaller, probably about the same. All right, but go through the big three, use context, and you got to pay attention to the details. Is it skewed? If so, you shouldn't be using the mean, and you shouldn't be using the standard deviation. Now, they did give us the numbers down here, so I should have been using those the whole time, right? So here we go. You can see that the means, see how the Wisconsin one's a little larger than the Vermont one, like we were thinking? Actually, that looks like the median is larger as well. I thought they'd be pretty similar, but it's larger as well. Standard deviation is way different, and that comes from the skewness, probably. Same thing. Like, we don't want to be using the mean. We don't want to be using the standard deviation. This IQR is about 100 and, or sorry, we got 80, 84, 90, no, 94. So 94 there. And then we got like 50 here, right? So this IQR is 50. So this IQR is larger than this IQR. Wow, to me on the picture, they look pretty close, but it's good to get the numbers. That's why you got to count them out, right? You got to actually count them out and find out where those medians, where the quartiles really are, so you can get accurate data. Okay, so we'd be saying larger on a lot of this stuff. The median for Wisconsin is larger than the median for Vermont. Blah, 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 right? The IQR is larger, blah, blah, blah. Okay, that's just a kind of quick, okay, compare your big three, get into it. I do have I kind of want to do the counting more on this one. This is a back-to-back stem and leaf plot. Hopefully you can see that this middle number is shared by both sets. These are like test scores in Ortwine's class and my class. So you can see there's a little key here. That's important. If you don't write the key, you'll get it wrong, or at least you'll have partial credit only. You won't get full credit if you forget your key. You got to say which is which, right? And labels are nice and things like that. I made it very minimum. I could add a lot more in here. I could put up the name labels at the top. I could give you a little summary of like the statistics down below here for each set. I could add a lot more into this. This is the bare minimum. All right, so if I want to compare these two sets, I guess the shape really, comes out at first, right? They don't really look normal in shape, but not too far from it. Are they symmetric? It looks like the Waka's class, my class, is fairly symmetric. This one isn't too bad, but this huge peak that's really close to the top numbers, the higher numbers, kind of makes me feel like it's skewed a little, but it's not bad. Like, both of these are fairly symmetric and unimodal for sure, right? They're both unimodal. It's like looking at the histograms, but sideways, right? You got to look at them like that. I mean, really, I would just say that it's not perfect, of course. I'd say they're fairly symmetric. They're unimodal, and they're not skewed. I wouldn't say they're skewed, right? If I was going to try to use a normal model for this, I think I would be okay doing that. It wouldn't be perfect, but models never are. Okay, so then what's next? We need the center and the shape, right? Or the center and the spread. We haven't done that yet. So this one, if I've done the work ahead of time a little bit on my piece of paper on the side here, this data set ends up, if you count them up, you're going to get a sample size of 40. I'll write it in. And this one has a sample size of 44 if you count them up. Okay, so when we look for the median and the quartiles, You just need to count them off. And yes, you have to do the work. You can't be lazy. You can't just say, I'll just guess, right? You really do need to count them. Even on a histogram, you should be counting it off and finding out where that's at. You have to spend the time to do it and be quick about it. So this one has 40. For the median, I'm going to look for 20. You start counting, you'll get halfway in between here, and you actually end up at 92. So this is right where, like I said, I did the work ahead of time just to save time for the video. So this has a median of 92. This one, if you do the count, you end up counting to 22. So you look at 22 and 23 and go halfway right in between those. You'll find out that you're right at 86, right in there. Okay, so that's where the median is. So which one's larger? Well, this one has a larger median than this one has. So Ortwine's class has a larger median test score than Waka's class does. Okay, notice how I put the context in on it. All right, and then let's look for the IQR. So now that I've cut 20, to get a quartile, you need to go 10 on this one. So in between 10 and 11. So if I count those out, you're going to be right in between 78 and 80. It's actually right in between these two values. So 78 and 80, halfway between those is 79. And then for this one, I have to go to 11 and 12. So I count off 11 and 12, and it's right where the 80. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So that one has a quartile, a first quartile of 80. Let's find the third quartile. So again, I'm going to go 10 backwards on this one. And you end up in between 95 and 96 right here. And on this one, I'm going to end up at 95, 95 right here. Okay, so what do we get? Well, this one had a first quartile of 79, the third quartile of 95 and a half. So that's 16 and a half for your IQR, 16 and a half. This one over here, we had a Q1 of 80 and a Q3 of 95. So that's an IQR of 15. So, yeah. So they're not much different, and you don't want to say, oh, they're way larger or something like that. Just say, it's slightly larger. You can throw in words like a little bit or slightly or a lot, significant, something like that. Okay, so the range, or sorry, the IQR, don't use range. The IQR for Ortwine's test scores is larger than Waka's IQR by 1.5. It's not that much, so just a little bit. Okay, so almost the same. All right, so we did we did medians, sorry. We did medians, we did IQRs for the spread, and then we've talked about the shape. So that's really all you need to do to describe two data sets. Use comparative language and make sure that you throw in some context. Talk about test scores, because that's what this is. All right, next up, the last thing I wanted to kind of talk about was re-expressing data. When you get a data set that's really heavily skewed like this one, I just made up some numbers. They don't really mean anything in this. There's no context to it. So, but you can see this has like a big 24, and then it's like 4, 4, and 3, and 3, and stuff like that, right? So it's really hard to kind of describe that and look at it, or it's really not useful. It seems kind of weird, right? So we're going to find out as we go along that we're going to want to re-express data in order to turn it into a normal shape like this. This is actually the same data. It's just been re-expressed. So what do we mean by that? Well, if you look at my spreadsheet, I just took a whole bunch of data and put in some numbers. And then I took the logarithm of that list and got new numbers. So these are all the log of these numbers, right? Log base 10. Oh no, log base 2, sorry. Log base 2. So this is the log base 2 of those numbers. When you do the log of them, it ends up transforming the data, and it doesn't always work with logs. Sometimes you have to do other things like do the square root, or maybe you have to square the data or cube the data or 1 divided by the data, right? Do the inverse. There's many ways that you can transform or re-express data. But if you can find the right one, you can change data that's skewed into a normal shape. Why is that useful for us? Well, if you can find a normal shape, you can use a normal model, And then next thing you know, you can use all those tools using z-scores and calculating areas under the normal curve, and gives you some powerful tools to kind of do inference with. We're early on, so we haven't really practiced things like using the normal curve too much and doing inference yet. So this will be more important later. But right now, you're getting used to, hey, there's this thing called re-expressing data that I can try different things and I could try to make it look differently. This also can occur when you're changing units. So if you're changing from yen to dollars, or gallons to liters, or whatever it is, if you're changing units on something, you might just by chance end up changing the look of your graph, um, just because of whatever your conversion factor is, right? Okay, so that's called re-expression. Just know it's out there. Be ready to kind of talk your way through it a little bit. You don't have to do too much work with it, but just kind of knowing how that it's out there and you can kind of make sense of it, right? Oh, we took the logarithm. The hard part is realizing that this down here now does not represent the original data. It's the log of the original data. So whatever values you're looking at represent the log of the data. So you'll have to, like, to get your values back out of it, you'd have to undo the log, like roll the log, right? This is log base 2, so you'd have to do 2 raised to whatever power to get back to the original data, right? 2 to the 5th will get you back to the original data value, that kind of thing. Okay, so just be aware of that. There's more information in the book. And, I got this problem from the textbook. There's tons of problems in the textbook. You should always kind of peruse through there, maybe do a few. It just gives you a good idea of the kinds of things that can be thrown at you on a test or a quiz. All righty. Thank you very much. Have a great day.